Now, before we go into the maths and the quadratic equation part of this question, let me just take you through a couple of more minutes regarding the actual process that's happening at the three different crossing, starting with crossing at t is equal to 0. So we know that the displacement and of p and q at t is equal to 0 is 0, which means right at the time of observation, they start the motion together from the same position. Okay. Now, at t is equal to 0, velocity of p is 20 meter per second and velocity of q is 8 meter per second. There is a reason why I have assumed that p is starting faster than q and is moving ahead. What is that? We will come we will discuss that in detail when we go through the topic, the nature of roots. Okay? So this is the first assumption. Acceleration, the initial acceleration of p is 0 meter per second square and initial acceleration of q is 16 meter per second square. I have deliberately assumed the value of acceleration of q to be more than acceleration of p, again for a reason. Because to have this motion as described in the question, q must get a strong push immediately and p should start from 0. Okay? And later, the second crossing, where time t is equal to 2 seconds, the displacement of p is 20 times t plus t cube. T is 20 times 2 plus 2 cube, giving you 48. And correspondingly, displacement of q is 48 as well. So they meet again at 48 meters. The velocity of p and q at t is equal to 2 seconds is 32 meter per second and 40 meter per second, which means q is faster in the second crossing. What I'm trying to convey here is, if the same question would have been given in a different manner, say statement one, the description is the same, and the question goes like this: consider the following statement. Statement number one: at the second crossing, car P travels faster. Statement number two: at the third crossing, Q travels faster. Statement number three: after the third crossing, Q leads P forever. And then we've been asked to pick the correct statements A, B, C, D, and E. Well, we never know, right? So that's the kind of extrapolation from the given question that I'm trying to do here. Okay. Now, why does this happen? Because Q catches P by 2 seconds, and because VQ is greater than VP at the instant, Q overtakes and move ahead just after 2 seconds. Okay. Now let's see what happens in the third crossing. This would have made more sense if this car would have. I'm really not sure what went wrong with the software. Anyway, so displacement of P is 336 meters at time t is equal to 6. Of Q is 336 meters as well. So they meet again at 336 meter. And when they meet, what is the corresponding velocity? The velocity is Vp is 128 meter per second and Vq is 104 meter per second. So again, the velocity is more for P than for Q. This means that P's acceleration has grown very large. So P catches Q again at time t is equal to 6 seconds. And because velocity of P is greater than velocity of Q, at that instant, P overtakes and moves ahead after 6 seconds. Okay? To summarize this, at t is equal to 0, they start together. P is faster. P goes ahead. T is equal to 2. They are together again. Q is faster. Q is ahead. T is equal to 6. P gains much of acceleration. P is now faster and moves ahead after 6 seconds. Okay. So this is the summary. I think if you write down this one and then read the question one more time and go through the graph that we were, that I suggested you to watch again, go through that graph again. Simultaneously reading this, things will make much sense to you. You'll feel yourself very confident at this question. Okay.